Hey everybody, I just wanted to take a little bit of time and go over how to sample problem here and how the integrated rate law may look. So in this case, I'm just looking at question B, and so it gives you a reaction. Okay, that reaction is 2A reacts to form B plus C, and data was collected. Okay, so here we have plotted 1 over A versus time, and here we've plotted the ln of A versus time. So in this case, okay, we should be able to see that this is a nonlinear relationship and this one is linear. Okay, so 1 over A we plot, and that gives us, that's a second order plot, but it's non-linear. So if it's non-linear, what does that mean? That means that this reaction cannot be second order. Now, ln of the concentration of A, we did that. That is a first order graph. We have plotted ln of A versus time. And that first order graph is linear, or at least we can assume is linear based on the shape of the curve. So that means that this reaction is first order. Okay, now, but that's not what it asks. The question here says write the rate law expression. Now most of you, because we just talked about this, would most likely be drawn to writing the integrated rate law. Let me just tell you that the rate law expression, this thing right here, is not ln A, all that, whatever, okay? The rate law expression is R equals K, now what's the reactance here? A, to some power. Now what is the power? Well, we just determined that the reaction is first order with respect to A. And A is the only reactant. So if A is the only reactant, it must be first order with respect to the whole. It must be overall, it must be first order. So we have rate, and we have rate equals the rate constant K times the concentration of A to the first power. Now, it says determine how you find the value of the rate constant for the reaction. It doesn't say to do it, it just says to explain how you would do it. Well, the reason why I like this question is because it intermingles both parts of the rate law, the differential rate law and the integrated rate law. So, and it really tries to get you to understand when you can calculate both, or when you can calculate the rate constant. And so how do we calculate the rate constant? Well, up until this point, we've really only done it by the method of initial rates. Well, we don't have several experiments, and we don't even actually have any data in here, so we can't use the method of initial rates to calculate the rate constant. But we do know from the integrated rate law that the slope of the graph equals the rate constant. Is this linear? Yes, it's first order, and the slope of the graph is equal to the rate constant. So how would we determine the value of the rate constant given this information? Well, we would calculate the slope of the line that is generated. Okay, it's basically as simple as that. Okay, so I hope that that kind of clears up some of the maybe some of the questions, and it shows how integrated rate law is related to just the rate law or the differential rate law. Okay, so have fun.